Assalamu alaikum. Welcome to my channel Mathematical Room. So in our today's video we are going to find some kind of trigonometric ratios of kind of special angles. So these angles are the 45 degrees, 30 degrees and 60 degrees. So these are the trigonometric ratios that we have to learn by heart, that we are going to use in our coming lectures. So these trigonometric ratios are very important ratios that we have to learn these ratios by heart, that in the coming lectures. So we will use these kind of trigonometric ratios with the angles of 45 degrees, 30 degrees and 60 degrees. So after, in my coming lectures, I am going to tell you about how can we draw a table of these kind of trigonometric ratios. So but in our today's lecture we are going to find the trigonometric ratios of 45 degree. So these are the ratios that I've already told you that we have to learn by heart, that if we use these kind of trigonometric ratios in some kind of questions, so we will put the values of these trigonometric ratios directly. So first of all, we are going to find the trigonometric ratios of 45 degree. So how can we find the trigonometric ratios? That you can see that I have drawn a square in front of you. So thus we consider that there is a square of like A. We can give the names that A, B, C, D, and you know that in the square all the four angles are of 90 degrees. So we can say that the square A, B, C, D, A, B, C, D is a square with all the angles of 90 degrees. So these are all angles of 90 degrees. So as you know that a square is a shape that with four sides and four angles. So in square all the sides and all the angles are equal. So if the square has four sides, you can say that AC, BC, DB and AD are the four sides, and the angles, four angles A, C, B, D. So in the square shape, that all the angles and all sides are equals with each other. So we have to consider that A, B, C, D is a square of length, you can say 1 unit. So consider a square A, B, C, D of side length of 1 unit. So 1 unit means that we can say that this side, all the three sides of the length 1. So because the sides of the squares are equal. So if we suppose that one length is 1 unit, then all the lengths will be 1 unit. So we know that if we draw a diagonal, then it will become a right angle triangle. So if we know that the diagonal bisect the angles, so if we draw a diagonal from A to B, then you can see that this square has become into two right angle triangles. So we know that the diagonal bisects the angles. So if we draw a diagonal from A to B, then these angles of a right angle triangle becomes into 45 degrees. So angle A will be 45 degree, angle B will be 45 degree. And angle C will remain as 90 degrees. So if you see the right angle triangle ABC, so in this right angle triangle you got the four angles. One angle is C, is a right angle triangle, and the other two will be 45 degrees. So A 45 degree, B 45 degree, and C 45 degree. Sorry, C 90 degrees in right angle triangle ABC. So in the right angle triangle ABC, right angle triangle ABC, measure of angle A is equals to measure of angle B is equals to 45 degrees, and measure of angle C will be equals to 90 degrees. So you can see that this angle A in this right angle ABC, this angle A and this angle B are both equals with the 45 degrees, and C is 90 degrees. So you know that all the sum of all the angles in right angle triangle will be equals to 180 degrees. So if you add all these three angles, so the sum of these all three angles will be 180 degrees. So now we have got the two sides AC and BC is equal to 1. So 1 can be a meter, a centimeter, or any other length, but we have the name of these sides as 1 unit. So 1 unit can be 1 meter, 1 centimeter, or any other length. So now if we will try to find the other side, or you can say the hypotenuse of this triangle, means the length of AB. So you know that we always use the Pythagoras theorem to find the third length of the right angle triangle. So if two sides are given of a right angle triangle, we always use the Pythagoras theorem to find the third length of the side of the right angle triangle. So by using the Pythagoras theorem, so what does the Pythagoras theorem says? That the square of the hypotenuse will always equals to the sum of square of the other two sides. So we can say that this angle is A, the opposite side can be named as with the small letter A. So this angle is B and the opposite side can be named as small b. And this angle is C, so opposite side means hypotenuse can be given as the name as small letter C. So where B is equal to 1, A is equal to 1, so we have to find the length of the C. So Pythagoras theorem says that square of hypotenuse is equals to square of sum of square of other two sides. So you can say the perpendicular side and the base side. So square of perpendiculars plus square of base. So can be written as a square plus b square. So if we now put the values as given in the figure that a is equals to 1 and b is equals to 1, then we can find the value of c. So c square will be equals to 1 square plus 1 square. So c square is equals to 1 plus 1 and c square is equals to 2. So if we have to find the value of c, then we will have to remove this square. So with the help of taking under root on both sides, so we can remove the sign as remove the square with the help of under root sign. So by taking under root on both sides, this 2 will be cancelled with this under root, so c will become as under root 2. So that's how we can find the length of the hypotenuse is under root 2 units. So now we have found the all three sides of the right angle triangle, so we can find the values ratios of the you can say we can find the trigonometric ratios of 45 degrees. So trigonometric ratios of 45 degrees can be written as, the first is sine 45 degrees, second one is cos 45 degrees, and the third one is tangent 45 degrees. So if we can find the trigonometric ratios of these three, sine, cos and tangent, so it's very easy to find the other three ratios, as the opposite of sine is cosecant, cos is secant, and tangent is cotangent. So as I have already told you the magical words that SOH, S-O-H, CA, C-A-H, and TOA, T-O-A. So sine is equals to opposite side over hypotenuse. S for sine, O for opposite, H for hypotenuse. So sine theta can be written as opposite side over hypotenuse. So O divided by H, that will be equals to the opposite side is A and hypotenuse is C. So that can be written as A over C. A is equals to 1, C is equals to under root 2. So that can be written as 1 over 2 under root. So cos 45 degree always equals to adjacent over hypotenuse. Adjacent side is AC so adjacent side is AC or B, which is equals to 1, and hypotenuse is under root 2. So cos can be written as 1 over under root 2. So you can see that the sine 45 degree and cos 45 degree has the same trigonometric ratios. So now if we find the tangent 45 degrees, that will always equals to TOA, T for tangent, O for opposite, A for adjacent, opposite over adjacent, 1 over 1. So 1 over 1 will be equals to 1. So these are the trigonometric ratios of 45 degrees. That sine 45 degree is equals to 1 over under root 2. Cos 45 degrees is equals to 1 over under root 2, and tangent 45 degrees 1 over 1 is equals to 1. So now we are going to find the opposite of sine theta. Sine theta, the opposite is cosecant theta. So cosecant theta will be equals to opposite of this side. You can say that under root 2 divided by 1, which is always equals to under root 2. So cos theta, the opposite ratio of cos theta is called secant theta, and that will be equals to, again, 2 under root divided by 1. That will be equals to under root 2. And the tangent theta, the opposite is cotangent theta. That will be equals to 1 over 1 will be equals to 1. So these are the trigonometric ratios of the special angles. We have started with the 45 degrees. So all the trigonometric ratios of 45 degrees we have found with the help of this figure. So sine 45 we have found 1 over 2 under root. Cos 45 1 over under root 2. Tangent 45 1 over 1 is equals to 1. And the opposite side trigonometric ratios of these three, sine, the opposite of sine ratio is cosecant, cos is secant, and tangent is cotangent. So we will have to just change the denominators into numerators. So that's how we can find that all the trigonometric ratios of 45 degrees. So these are called the special trigonometric ratios of special angles. So I've already told you that we got the special angles as 45 degrees, 30 degree, and 60 degrees. So we have found the trigonometric ratios of 45 degrees, all the trigonometric ratios of 45 degrees. So these trigonometric ratios we will use in our coming lectures when we will solve the questions about the right angle triangles as given, sometimes given as angles, sometimes ratios, and sometimes sides. So these are the ratios we have to find we have to learn by heart that if we say that what is the value of sine 45, so we will have to know that this is 1 over under root 2. If someone asks you what is the trigonometric ratios of 45 degrees, so we will say that the secant 45 degrees equal to under root 2, or someone asks to what is the value of cosecant 45 degrees, so we know that that will be equal to under root 2. So I have written the theta over there, but I should have written over 45 degrees because we have found all the trigonometric ratios of 45 degrees. That's my mistake. I apologize for that. So these are the trigonometric ratios of 45 degrees. So in my coming lectures, so we will find the trigonometric ratios of 30 and 60. So inshallah, I will see you in my next lecture. So hopefully you will, when you will watch this video, you will understand that how we have found the trigonometric ratios of this special angle of 45 degrees. So inshallah, I will see you in my next lecture. तब तक के लिए इजाज़त दीजिए। खुदा हाफिज़।